So let's start. First of all, thanks for inviting me to Øredev. I've been here in 2019, and I really enjoyed the conference. So I'm so glad to be here speaking about a completely different topic. Well, not different, but yeah, different topic, but not too far away from the topic I used to talk about, which was observability. So today we are going to talk about web application firewalls, but in a revisited web application firewalls, right? Everyone, I guess most of us have in mind something about it, and probably something old about it. So today we are going to revisit that vision and see opportunities. So before I start, let me introduce myself. I am José Chávez. I am a software engineer at Tetrate. Tetrate is a software company focused on service mesh. We deliver security features on top of service mesh, mainly in Istio. We are also one of the biggest contributors to Istio and Envoy. So we are mostly in the cloud native area. I'm an open source and security enthusiast. I'm working in open source for around 8 years now. Security is like a couple of years. I started in security by accident, I would say. I am the OWASP Coraza WAF co-leader, which is the project I'm also talking about. It's a security project, as you might think. Zipkin core member, and a loving father of 2. So, web application firewalls, or WAF for friends and family, right? Traditionally, a WAF, and this vision comes probably from the 2K, from the 2000s. It helps you to protect web applications, but filtering and monitoring HTTP traffic, right? Between the web application that you deployed, probably a monolithic one-instance application, and the internet, right? It protects web applications from malicious traffic, cross-site scripting, remote code execution, file inclusion, size payloads, all this kind of malicious traffic. Like whenever they try to hijack your server. It's mainly deployed as a Protocol 7 defense in the OC model, right? Because it deals with HTTP elements, right? As opposite of, for example, TCP, which is layer 4. And it usually works as a reverse proxy in front of your server, right? In front of the main entry point of your system. And then the WAF is, as I mentioned, filtering and monitoring all the incoming traffic. And it produces audit logs with more detailed information than you will usually see, right? Headers, body. So you can, according to the feedback provided by the WAF, you could, let's say, understand what is happening in the traffic, right? This is the traditional vision. Graphically, what you can see is this, right? You have an attacker, you have an app, you have a device, a legit visitor, for example. Then you have the WAF in front as a firewall, as the name says. And then you have your server, right? And you have a perimeter boundary, which basically says like, okay, from this line to the left is insecure, from this line to the right is secure, right? I can trust. This is usually the way we deploy WAFs, or the way we used to deploy WAFs. Some of the most popular WAF features are IP fencing, for example. It means that you create a fence and you will only allow incoming requests from a certain list or block requests from a certain list of IPs, right, through a denied list. Then you have geo-fencing and geo-blocking, which is that based on a geo library, like geo-IP, for example, you will resolve the country or the city from an IP and then say like, okay, only traffic from Europe is allowed, only traffic from the US, only for certain country. And then you will draw a virtual perimeter around your system, right? Then you have request and response inspection, looking for exactly that kind of malicious traffic, like injection, cross-site scripting, zero-day attacks, right? Whenever they, for example, if you remember Log4Shell, you will think of a zero-day attack where it was through a query parameter where they will exploit in your system. And all this is analyzed in the elements of the incoming request and the outgoing response, right? Headers and body and so on. Then you have security rule support. Like if you ever heard about, for example, CoreRuleSet, which is a curated list of rules that will prevent well-known attacks, right? For SQL injection, for XSS, for local remote files inclusion, for site restriction, for, mainly for that. And then you have another concept called anomaly scoring. Anomaly scoring is basically whenever you receive a request, when you are detecting anomalies in that request, for example, a deviation in the URL or an SQL injection, you will give a score to those threads, right? A deviation on the URL will only give you a low score, but an SQL injection attempt will receive a better or higher score, meaning that the overall score will determine through a threshold whether I should block or not this request, right? This is one of the features, probably one of the most popular features of a WAF. Then you have rate limiting to avoid DDoS attacks, right? Based on IPs mainly. That was, or that's traditionally how it works, based on IPs. And bot mitigation, which will analyze the cookie sent from the browser, and then it will determine whether this is a legit request or not. Or this is the classical case where you receive a CAPTCHA, for example, because of the cookie is not or doesn't have a good reputation, the information included, and then you need to resolve whether this is a legit traffic from a human or it's a bot. And yeah, as I said, traditionally WAFs come from like around 30 years or maybe 25 years, right? Because there was a time where WAFs were very popular, and basically your security depended on putting a WAF in front of your system, right? And if you needed more security, you put yet another WAF, and then you feel much more safe, right? But as history told us, it takes just a horse or a Trojan horse to take down the kingdom, right? And this is because usually the vision was that the attacker was outside the system. But what if the attacker is already inside, right? Or what if the attacker will be eventually inside, right? What if it took the control of the container, it took a pod, or it found a backdoor to get into one of your let's say, your components, and then it's trying to compromise other components from there. This is because perimeter security, which is basically on which WAF is based on, like remember that line which draw the perimeter, has some challenges nowadays, because we are not anymore in the, let's say, in the classical way we deploy things, where we just deploy things in our let's say, on-prem data service, and then we are okay because we close the door and then we are safe, right? Or we just restrict the traffic from the inside certain IPs or from inside the office, and then we are safe. Because now in the cloud era, we have that there is no single identifiable perimeter, right? Because you have different ways of deploying applications. You have cloud, you have on-prem, you have hybrid, you have multi-cloud, you have third-party services, you have function as a services, lambdas, for example. You have artifact registries, which your system will have runtime access, right? Because they have to download the artifacts, or the Docker images, for example. That's one example. And also, the majority of the traffic in a microservice architecture is not from the outside to the inside, but it's more like a horizontal traffic, right? Service-to-service communication. A request traverses now dozens of services, meaning that there are, for one request coming from the outside, there will be dozens of requests between your services that you need to make or provide a security posture about, right? East-west is a term, right, for horizontal communication, right? North-south is from the outside to the inside. Another problem with security is that the main gateway, the ingress, need to know a lot about the internals to provide the rules accordingly, right? If I inside have services in PHP, services in Java, services in Go, the ingress has to basically take into account what are the different technologies, the different libraries, and the different threads I have inside to provide the rules accordingly, causing overhead, operational complexity, misconfigurations, because now the configuration gets much more complex, right? Timely policy updates, etc. And also, the guiding principle for perimeter security is trust but verify, right? Let them in, but then verify whether this was legit or not. And probably by the time you verify, you're already compromised. You already have a data breach, right? You leak information already. So these are the challenges with security, with perimeter security. And then is how the concept of zero trust was erased, right? Which is enabling the right user under the right conditions to gain right access to the right resources. Everything is right, right? But zero trust doesn't mean that you don't trust anyone, because that will be crazy. You have to trust someone. Zero trust actually means zero implicit trust, right? You don't trust anyone by default, or at least if you trust by default, then you do it as a conscious decision, right? The other day, for example, someone asked me, how do I trust, for example, Docker Hub images, right? Because zero trust is trusting no one. No, it's not that you don't trust no one. It's that you consciously decide to trust those images, whether you run your own scans or whether you trust those images because they are community built and then they might be safe, they run audits and all that. You decide to trust them. But it's a conscious decision. It's not that you say like, okay, I will trust until I see something negative. Zero trust is a term for an evolving set of cybersecurity paradigms that move defenses from static network-based perimeters to focus on users, assets, and resources, right, which are more dynamic, right? Before you had a server or a bunch of servers, statically, let's say, a static number of servers, static number of endpoints, and then everything was easier. But now you have lots of things. You have ephemeral containers, you have Lambda functions that scale at their own pace, that you don't know how many of them they are. You just know that they work, right? And you have lots of users that you cannot keep track on because now you have guest access. And you also have a lot of devices that are compromises. You have auto-scaling groups. All these kind of things are dynamic. You cannot anymore trust in a static way. This concept, by the way, was developed by the NIST. And ever since they defined this, I think in 2012, there was a law as well for moving in the US, moving towards zero trust compliance for contracting with the government. So yeah, this is getting a big movement, and that's why we also think we should think of firewalls in terms of zero trust, right? Some of the assumptions for zero trust are that trust can no longer be based on a network perimeter, as perimeter can always be breached, right? It takes only one to bring down the perimeter to compromise your entire system. Policies have to be defined based on the assumption that the attacker is already inside your network, right? So everything, that's why it's very important that you don't do anything implicit, because if the attacker is already in your network, the moment you make it implicit, that means that there are blind spots where you don't know, okay, does this attacker have access to this, or what does this attacker have access to, right? Because if it's implicit, if it's not explicit, you don't know. All access decisions have to rely on least privilege, per request, and context-based principles, right? That means that you cannot only analyze the request in isolation, right? You need to provide much more context. If your request is bouncing different services inside your network, you need to also look at the security posture on every hop in the request, right? And also you have to look at identities associated to the user, to the services, and to the devices, because zero trust is more like everything is a resource. So everything might have an identity. There might be a security posture around everything. User, services. It's not only like, okay, the user is logged in, so I can trust, right? It's the user is logged in, but can I trust this user? Can I trust this user in this context? Right? Can I trust this user accessing to this resource? Can this service access to this resource? Can this workload in this cloud access to this other workload in this cloud, right? all these things take in consideration. For example, if you think about compliance, where data from banking, from the US banking, can only be stored in US servers, but this is an international banking with, let's say, data centers everywhere, or hosted in the cloud, but everywhere in the world, then you need to have different policies, so this guy from the US cannot or cannot store data outside the US, right? These kind of policies are the ones that are taken in consideration when you talk about zero trust. And security and access state change over the time, right? This is specifically interesting because there is a big quote in software saying, like, if something works, don't change it, right? That's usually what you do, right? If something works, then you don't, just don't move it. If it works, let it be. The problem is that that's based on the assumption that the condition is going to remain the same. But in security, the same software that was compliant and that was secure, at this specific second, might be unsecure and might be exploitable in the next second because they disclosed a new CVE. The piece of software, the binary, didn't change. The deployment didn't change. The network didn't change. Nothing changed. Well, it changed. The time changed, right? And with the time, the information changed, and then now you have a new vulnerability published. So this quote doesn't work for security, right? Something could work now, but it could be secure now, but in the next second it could be not secure anymore, and nothing have changed. So security is not a property of your system, right? Security is a process, it's an ongoing thing, right? You need to check security in every second across the time. It's not like I am secure, okay, I'm good. Zero Trust have some tenets that support all this philosophy. Well, it's not a philosophy, it's more like a strategic thing, mindset, let's say, right? All data sources and computing services are resource. That's something I mentioned before, right? You switch from static servers and endpoints, right, which we used to have probably a monolith and all that, with a static endpoint, and you move now to a cloud computing services, such as pods, which are ephemeral, which live for some minutes, and then change, and function as a services like lambdas that they are deployed like at their own pace, and you cannot keep track of them, basically because that's the burden you want to delegate to the host, right? And hence is dynamic, right? So you cannot, sometimes it's hard to do, let's say, static policies or static assessments of security in something that is dynamic, right? When it's a static, it's easy. You just say like, okay, this number 1 is okay, this number 2 has access, this number 3 is compliant. With dynamic things, it's much harder. Also, these pods and these function as a services have their own security or their own access requirements, right? So how can you control these when you don't even know if they exist or how many of them are there, right? So yeah, dynamic. Communications are secure regardless the location, right? That's basically saying perimeter security is not enough. You need to have a policy access of default to deny by default, and you give explicit access and granted to specific resources every time. Right? You cannot say like, yeah, because I am inside the network, I have access. And by the way, I'm not saying like other network mechanisms are wrong or they don't work, right? If you want to do that, that's also worth. But you cannot only rely on that, right? In security, it's not that there is a silver bullet that fixes everything. It's more like you pile up layers of security so you are much more protected, right? I'm not saying like VPN or IP restrictions are bad. I am saying like they are not enough. You need some other mechanisms on top. Access to build individual resources is granted on a per session basis. Yeah, that's also something I was talking about, because the fact that you trusted a request now doesn't mean that you have to trust the same request with the same payload in 5 minutes, because things could have changed. Policies could have changed. So every decision must be done in real time. You might be wondering, okay, what's the latency? What's the overhead added? Because if I have to check every time, there are other mechanisms. That's a different problem. The tenet says that you shouldn't trust, like, because I trusted once, I need to trust forever, right? This is one of the key things as well. Access to resources is determined by dynamic policies and contexts, right? Because several attributes might come to play when you make a decision, right? It can be a distributed trust schema where, while your request is bouncing across your components, you take a security posture. Then you decide whether I have access to every single hop, but in the end, the overall security posture can also be considered, right? Because each one is going to add a new label of, let's say, compliance or security, right? It's so important that you keep the context to make a decision. You cannot just say, okay, like blindly resolve a decision access based on one single, let's say, one single piece of information. You need to keep track of the context, of the metadata, of the request. Maybe different pieces of security analyze will give you different size of the information about the security posture, and then you make an overall decision. Then also things like environment come into play, roles of the user, and metadata of the user, if you think not only on the typical role schema. If you talk about, for example, ABAC, with resources have different attributes with different values, not only focus on the role. These kind of things are the ones that come into play for Zero Trust. Monitor and measure integrity and security posture of the assets, right? This is very important because now that we are in the era of CVEs and zero-day vulnerabilities, where we have a deployment that had a container image that was safe, but not anymore because of a CVE was disclosed. You need to keep monitoring what you have deployed in your system, right? That you have up to date with the let's say, with the security patches on your images, on your binaries, or whatsoever you have. And you should run continuous monitoring on whether that is still true, right? Like a compliance check. Dynamic resource authorization and authentication is strictly enforced before access allowed. This is specifically interesting when you have, let's say, when you are performing a request, and then before you give access to the resource, you should check, as I said, like, can this request access to this resource? Can this user access to this resource? Can this service ping this other service that is going to return the resource? And these kind of policies should be enforced right before you give access, right? Meaning that, for example, things like sidecar come into play into here, right? If you heard of sidecar in the Istio or in the service mesh in general world, is a pod or is a workload that is running along with your service, proxying all the incoming requests, verifying whether this can access or not, right? These are the kind of, let's say, a resolution you have in front of your resources. And then collect info on the current state of the asset, right? Network, infrastructure, communications to improve security. And this is basically coming back to what I was talking about, audit logs, right? You have different kind of audit logs produced by different kind of security components that will provide you more or less an idea of what is happening in your system, right? What are the ongoing threats? What are the let's say, the anomalies that are happening in the traffic? And then you from that, you should learn and deploy new security rules, right? This is basically the logical components of Zero Trust architecture. This is, of course, very simplified to what we care about. We have an untrusted zone. We have a policy decision enforcement point in the middle, and then an implicit trust zone. From the PEP and the PDP to the right, you can trust everyone. You don't need to authenticate whether they have yachts, whether they, basically you don't validate IP, where it comes from. Basically, that's the implicit trust zone. You decide where's the limit, right? If it's a sidecar, then, okay, all the traffic coming from the sidecar, I don't do any sort of validation, I just trust. From the outside, you validate everything, right? That's why I was saying, like, it's not about not trusting anything. It's more about, like, okay, I draw the boundary and I say, like, from this on, I will trust. And you might be thinking, but is this some sort of perimeter security? Maybe, but it's at a different scale, right? A much more controlled scale. Like it's more local, right? It's not that you have one single ingress that holds all the protection to your system, right? So, with all that said, is how we started thinking about a zero trust-based application firewall, right? A zero trust web application firewall protects workloads by filtering and monitoring traffic between workloads at PEPs. That means that service-to-service communication should also go through a WAF. And you might be wondering why on earth I am running a WAF in front of every service communication. Because it could happen that the attacker is already in service A. It managed to download a curl through a shell and start doing random requests into service B to try to exploit vulnerabilities to, for example, try to, there are some, let's say, there are some frameworks or libraries that expose more data than you might want to expose, the language version, or what was the version of the compiler at that time, or what are the software bill of materials, right? And then attackers might get into one workload and try to obtain that information to attack them, right? To steal data, to breach data, to kidnap storage, these kind of things, right? Then you must protect every incoming request, even if they come from another service inside your cluster, inside the same network, inside your deployment, right? Of course, not at the same level as you will run up in the ingress where the risks and the number of threats are much more bigger, but you still run it at a different scale. It leverages wide network patches for zero-day vulnerabilities. If you remember Log4Shell, when people was basically attacking Java services because of the Log4j logger library through a query parameter. It took a while until they could patch the Log4j, because it was around Christmas as well, until they could patch the Log4j library, and then that patch made into a release, and that release made into your dev environment, and that new commit in the dev environment made it to production, and then a release, and then a deploy to staging, and then a deploy to production. You see, it's a long process. Whereas, if you have something like a WAF deploy, you can just release a network patch where say like, okay, this is the regex for the query parameters that provoke this attack, just deny them. And then it gives you time until you can actually properly deploy the fix, because no matter how fast the library gets patched, it will take a while until you make it into production. Or even worse, maybe it's code that you don't even know how to build, or that you just have the binary because it's a IBM macro or a Prolog something, or Fortran compiled, and you don't want to touch it, right? It allows to onboard legacy application in a lift and shift fashion. Lift and shift is basically, I get my legacy application, I put in a virtual machine, I put it on the cloud. Right? I don't change anything. I don't rebuild, recompile anything. It carries all the vulnerabilities and problems that it already had, because it's an old thing that nobody maintains, or maybe nobody knows how to build it, that has no tests or whatsoever. And then once I put it in the cloud, I potentially open the door for any attacker to attack it, right? This is when you put a WAF in front with all the well-known attacks covered to make this workload to run safely. It also provides a flexible rule set based on application internals and security posture, right? Because every application has its own risks, its own potential threats. Every language has an own set of problems, right? And then WAF should allow you to only selectively deploy those rules that will work for that specific application, right? That's why you should have access to flexible rule sets. And also security posture, because maybe it's not the same protecting the payment service or the, I don't know, the photo service, right? If your business is not a photo, right? If it's just one field in your profile. So you need to have different security posture. Maybe you run a paranoia level in the payment service, which is 9, but paranoia level in the media service, which is 2, because and you might be wondering, why don't I run a consistent paranoia level across all my components? It's because it's costly, because it adds overhead, because it adds latency. So you should be wise to choose. It's okay if it takes 3 minutes for a payment to go through, versus it's not okay if you are Google and you are running a security, or not a security, but a text search, and you respond in 200 milliseconds, right? It's all about trade-offs on where it's okay because it's more safe, or because it's more risky to run longer validations, whereas something you really need to have zero latency or very small latency because it impacts your revenue, right? This comes from, for example, observability, right? How observability started? Well, Google started connecting the latency in the text search with the revenue, and they saw that the longer the search took, the less revenue they have. That's why observability was born. Same with security. You make the trade-offs so you don't impact your revenue. In the end, you're a business, right? It should provide audit logs for further analysis and improve security posture through adaptive rule sets. What is it about? It's about looking at the logs, processing them in an automated way with machine learning, AI, whatever you call it, and then come up with new rules because you detect anomalies, because you detect ongoing attacks. It's kind of what you do with, for example, rate limiting. But rate limiting is very specific, right? You count the requests over a window and then say, like, okay, I will block this request. But if you go in the bigger picture and you look at the logs, and then, okay, you say, with all these logs, I can see that these are anomalous behaviors. This application with this kind of payload is producing much more errors, or even the returner payloads are about SQL errors or whatsoever. Then, okay, I will take a measure accordingly, right? It's basically learning from what is happening. And why is this important? Well, for many reasons. Because you want to be secure, because a lot of lift and shift is happening in the world, right? People is moving from on-prem because it's hard to maintain, expensive, of course. There are trade-offs as well there, right? There are banks that will prefer to keep it on-prem. There are companies that will prefer to move to the cloud, whatsoever, but it's happening, right? People is moving because they have more options. They are choosing as well to move into the cloud, although they have legacy services. Because service mesh leaders are waiting for a WAF to happen, and because of PCI compliance requirements, right? In 2025, a WAF is going to be a requirement for any website that runs transactions with cards. So that's why WAF is becoming very important. I know I'm running out of time. OWASP CoreRuleSet WAF. It's an open source web application WAF. By the way, I said like I am co-leader for Coraza, for OWASP CoreRuleSet. So yeah, this is what we are working on. It's an open source web application firewall, which might mean like meaningless, but look for other open source web application firewalls in GitHub. You won't find any. Well, mod security, right? But it's dying. It's written in Go. It's inspired by mod security and supports seclang, which is the configuration language for mod security. But the end of life of mod security is in 2024. It focused on CoreRuleSet before, which is going to be launched soon. They are in RC2, and is the newest and shiniest curated list of rules for known attacks. And the version 3 received a production flagship from OWASP, meaning that you can run it. It's safe to run this in production. It has multi-platform connectors. You can use it in native Go, because it's a Go project, so you can just include a middleware, and it works. You can run it into Kali, because we have a connector. Traffic, we have a connector work in progress, driven by the community. You can run it in Envoy, Istio, Kong, through the proxy WASM spec. And it's fully compatible. By the way, proxy WASM is a way to extend a proxy, or mainly a proxy, because proxy WASM, right? Without recompiling. You just load a WASM binary, then there is a let's say there's a runtime, it's an Envoy or Kong that will load that WASM binary and run it. And the performance is not native, but it's close to native, or at least that's the promise, without recompiling the Envoy, right? If you need to include a new Envoy filter, for example, in C++ for WAF, then you will have to recompile your own Envoy, and then it's, trust me, maintaining an Envoy fork is terrible. It's fully compatible with WebAssembly, which allows to run it in different stacks. And this sounds iniquitous, but it's actually very powerful because you could run it in different languages through a runtime. For example, you can run it in Rust, you can run it, well, in Go is native, you can run it in Envoy, which is a C++ project, or you can even run it in the browser, because you compile it into WebAssembly, then the runtime in JavaScript allows you to run it. Actually, our playground runs entirely in the server. You know, we're a security project. We don't have to maintain a server because it's too risky. So we have everything running in, although this is a Go application and you typically will deploy it in the server, we run it in the front end through WebAssembly. So yeah, different stacks. Basically, you can run it pretty much everywhere. You don't need to run Go for running Coraza. Pluggable architecture, we have a set of experimentos plugins API for extending the functionality and write custom WAF filters. Like in the last Google Summer of Code, someone brought a rate limiting plugin. Someone just brought a GeoIP plugin for this. It's focused on high throughput because, as I said, we run it, or we want to run in every single service inside deployment. So performance is the main focus. And it runs in the hot path, so latency and overhead should be minimal. It's portable and easily distributable because, of course, if we can compile to WebAssembly, you can just leverage as an organization-wide policy, right? Basically, you can distribute those WASM binaries and then load it, and you don't need to change the code. That's the promise. So, conclusions. Zero Trust isn't incompatible with network perimeter-based approaches. Both are needed. And whatever else you think will help, it's also needed. In security, unlike in life, less is more, right? In security, less is less and more is more. So you go more, right? Web application firewalls are still relevant to achieve inter-resource communication, right? Not anymore so as something that you run from the internet to your application, but more like resource-to-resource communication. And security is a dynamic process, right? Not a static attribute of your system. So, thank you so much. Thanks for coming. Not sure if we have questions or time for questions. Anyways, I'm on Twitter, I'm on LinkedIn. This is a list of reference of things that are worth to read. So yeah, thank you.